very much.
Thank you very much, Chris. And I can assure you that this is not about hope, but expectation. I thought I'd use that. As Chris said, I'm Duncan Ockendon. I'm Sales Director at Aquaservice UK. I won't do a slide on this, but a brief background. Aquaservice celebrates its 40th birthday this year, and it's a Norwegian-based. We are a Norwegian-based company specialising in the engineering of HDPE materials. Now, the majority of our work has been in Norway, servicing the aquaculture market with items like ribs or boats and utility barges. But just in the last year, we've extended our offering into the aquatic sector with two product lines, UV systems and self-cleaning filters. But unusually for me, I come from a UV background. I'm not going to talk about the technology of these products so much as the materials, because this is novel. UV systems are traditionally made, the chambers are made from 316L stainless steel almost exclusively until now. So I'm going to give you a little talk about corrosion and the background behind it, because it is a belief in certain quarters that if you're using stainless steel, it is completely impervious to corrosion. And I'm sorry to tell you that that is not actually the case. There are different degrees of resistance, and there are different grades of stainless steel according to the situation and circumstances. And the images I show here, now there are various types of corrosion that can occur in a swimming pool plant room. I'm calling this environmental corrosion. So these are two UV chambers. The one on the left is installed outside Rome in Italy, and that photograph was taken 14 months after it was installed. So quite clearly, it didn't leave the factory in that condition. And it's probably that corrosion due to atmospheric conditions, high humidity, high temperature, and more than likely some chemical releases from mixing perhaps hypo and acid. But when I talk about the environmental conditions, the little meter on top of that unit is a hygrometer, and it's measuring the humidity at 66% relative humidity, which is not particularly high because the recommendation is for a maximum of 95%. Now, this form of corrosion is actually not as serious as it looks because it's surface mainly, but nobody wants to see rusty equipment in their plant room. What is somewhat more serious is a form of corrosion called crevice corrosion. Now this occurs, excuse me, this occurs in what is defined as a crevice in this case, is a very small space between adjoining material components, and it's as small as between 0.1 microns and 1 micron. Now stainless steel, it protects itself from being corroded by a layer of oxide that forms on the surface of the steel. And it's that oxide layer in a pool will be attacked by chloride ions, but the steel replaces the oxide with oxygen drawn from the surrounding water. But in these small crevices, the water's starved of oxygen. So somewhat surprisingly, this type of corrosion is actually indirectly linked to an absence of oxygen rather than its presence. This is quite more serious than that surface corrosion, because these crevices occur on a UV chamber between, say, a flange and the body of the chamber. Any clamps that would attach, say, instruments like UV intensity sensors, temperature sensors. It can also occur on welds and also beneath dirt particles. The effect of this corrosion is, I mentioned chloride, that's the aggressive agent, but it's also very much influenced by the water temperature. But I will show you a few examples. So these are examples of crevice corrosion on UV chambers. On the far left, you see the end plates removed from a UV chamber, and that corrosion around the rim is crevice corrosion. Here in the center, that's a UV chamber that was installed or is installed still on an aquaculture application. So the water is seawater. That's where the chloride comes from. But in this case, the setup was allowed the UV to run at full power when there was virtually no water flow. So the UV lamps heated up the water, and to a degree where then the chloride attacked within the crevices. So you see leakage of ferric oxide coming out of where the lamps would be connected into the chamber. And further down here is a different site. That one actually comes from British Columbia in Canada, where that's the connecting point on the chamber where a lamp would be connected. Now, the reason that this type of corrosion is more serious is that this leads to leaks. And ultimately, you could have a flooded plant room, but you certainly have a failed chamber. And to replace the whole unit is extremely expensive. So a lot of the UV manufacturers have been aware of this issue for some time, and so I'll come on to their solution. The effects of chloride concentration and temperature are the two factors that are crucial to this. And this rather complicated chart is from the Nickel Institute. And I don't know if you'll still catch my voice, but there are the diagonal lines show different grades of steel and the risk of either crevice or pitting corrosion occurring. Now, pitting corrosion is somewhat different in that it occurs when contaminant inclusions in the surface of the steel become eroded away. Now, that's to some degree overcome by passivation of the stainless steel by processes like electropolishing. So it's really not so common as crevice corrosion. I don't know if you can still hear me when I move away from the mic, but what I'm wanting to draw your attention to is this line here. So this is the likelihood of crevice corrosion occurring on 316L stainless steel at a given concentration of the chloride ion against temperature. Oh, thank you. Thank you, Chris. Sorry. So I'll just repeat that. So this chart shows on the horizontal axis concentration of the chloride ion in the water, and on the vertical axis, the water temperature. And if we look at, say, a typical pool condition, let's say around 30 degrees Celsius, we go across this line here and drop down. That indicates that at a concentration of just 400 ppm, or milligrams per litre, thanks, Chris, there is a significant risk of crevice corrosion occurring. Now, the sources of chloride are somewhat multiple. One source is the source water, and as an example, I have had experience in the past of this phenomenon occurring in Western Australia, where the pool source water was borehole water, which was brackish, and had a concentration of chlorides in excess of 2,000 milligrams per litre. So that's an example of source water. We don't get that sort of issue in the UK, fortunately, but it will come with its own incoming TDS load. And then the second most obvious source are from the bathers themselves, who introduce salt and chemicals into the water through sweat and urine. I used to swim in a pool near to where I used to live, where the water tasted salty, and it didn't use electrolyzed salt chlorination. That salt came from chemicals used for disinfection and from the bathers. And if you can taste salt in the water, excuse me, there is sufficient chloride there to bring about corrosion. I mentioned, I mentioned Thank you, Chris. My apologies. I touched on disinfection chemicals are also a source of chloride. And I think more significantly these days, salt electrolyzers. So there are a number of these products on the market. They're becoming increasingly popular, where salt is electrolyzed within a cell and it produces sodium hypochlorite and, as a byproduct, hydrogen. But not all the salt is electrolyzed. Many of them allow up to 50% of the raw material, shall we say, salt feed, to pass through the cells unprocessed, and that salt goes into the swimming pool. And I expect, because of the increasing popularity of these electrolyzers, against which I don't make any derogatory comment, it's just a fact, they are here, but it's also a fact that they introduce salt into pool water. And unless that pool operator dilutes rigorously enough to keep the TDS in the pool water down below PUTAG recommended limits, there will be more and more cases of crevice corrosion happening. So as I said a while back, a lot of manufacturers are aware of these issues lying behind this. It's not because they are supplying an inferior grade of 316L stainless steel or that the products are defective. It's because the material itself is just not capable of withstanding attack by chlorides at the sort of temperatures that we see in swimming pools. So the three main solutions are used. One is by using more corrosion-resistant steels, but there's no steel that is fully corrosion resistant. One type of steel that's used is called super duplex steel, which contains a 25% content of chromium. And it's pretty successful, but it's very expensive. It's a very expensive material. So there's an economic consideration here. Another solution is to use sacrificial anodes. So these are anodes that are installed within the UV chamber, and they degrade sacrificially to save the steel body of the chamber. And they also work, but they are consumable parts that need changing. But I would say the more significant issue is that they are introducing metallic contamination into the pool. The sort of materials used for these anodes are typically magnesium or aluminium or zinc. And zinc in particular is not a good material to have in pool water. So a third solution is to use a polymer, specifically HDPE, and not HOPE, but high density polyethylene. This is a widely used material. Some of you may use it in components in your pool equipment anyway, but it's got a very high strength to density ratio, and although it can withstand temperatures of up to 120 degrees Celsius for short periods, that's its softening point typically, but we will limit that to less than 55 degrees Celsius, so there's no risk of any softening occurring in the unit. It's widely used in a number of applications industrially, including food storage containers, so that there's certainly no issue with it being a challenge to the health of the bathers. And I think quite significantly, it's a recyclable material. So at the end of the long life of these units, and I'll talk about lifetime shortly, the material can be reused. So in terms of sustainability, it ticks an important box there. So because this is a new material used in UV systems, there will be questions raised. Does it actually work and does it last? Well, I'll give you a few examples. Starting with a wellness pool. This is a flotation pool in the Netherlands, and flotation pools mimic the water quality and consistency of the Dead Sea. So they contain a very high percentage of dissolved solids and are highly aggressive waters. This UV system was installed in 2019, and the photograph was taken last month. And the only thing you can see in the plant room and on the chamber are traces of the salt from leaked water, but none of that leakage occurred from the UV chamber. It is in perfect condition and perfect operating order. So an older installation, but this is not a leisure or aquatics application. This is on a cooling tower disinfection plant in Cyprus. And there are 4 UV systems here. Each of them holds 10 2.1 kilowatt lamps. So, i.e. within each of these 4 chambers, there's at full power 21 kilowatts of power. So you really cannot get a more intense UV radiation than that. And this was installed in 2009, so that's 17 years old. This next photograph was taken 10 years after the installation, when a major overhaul of the plant occurred. And you can see it's not a clean site. So what you can see on these 2 chambers is general dirt from the environment, because it's not closed in from the outside world. But on the chamber on the left, you can see the interior, and the outside has been cleaned. It's in perfect condition. The units are still in operation, and the chambers are in absolutely perfect condition even now, as long as they're cleaned. So something that's applicable to the UK. This is our first UV installation of this sort of equipment in the UK. And these 2 units were installed and commissioned last week. The second of them was completed just last Friday. So this is really hot off the press in terms of news. Obviously, systems that are only a few days old after installation are not going to show much in terms of lifetime, but they are already here in the UK. So I'm going to move on from UV now. As I said, I'm not talking about the UV technology itself, but it's the material that we're talking about here that's different. Filters. Now this is a self-cleaning wedge wire filter that it uses a technology that's also somewhat new to the UK. I don't really want to focus on that, but on the fact that the housings for these filters are also of the same grade of HDPE, which is a weldable material. So one of the advantages of this material is that it can easily be welded and repairs are very simple. But the filter does have certain performance features, which I've mentioned here. Now, traditionally, filters are made of, there are also stainless steel filter vessels. These are 2 of the more common types of material. So on the left is a mild steel filter with a lining. And in this case, although it's not very clear, the photograph is of a lining that's completely delaminated from the shell and has fallen over the laterals. And obviously, if you don't have a lining or a sealant on the inside of a mild steel filter, it will corrode. And on the right is a GRP filter. also very commonly used. Probably an expected life of 15 years. Over a period of time, the sides will start to bow out, there'll be leaching and there'll be leakage. So there are time constraints on both types. So the Aquaservice designer filter was first launched 40 years ago, and the very first filter of that design is still in operation. And in fact, it was serviced 3 years ago. The interior mesh of stainless steel was replaced, but the HDPE housing is still in excellent working condition after 40 years. So I'm hoping I have gone within my time limit, so I've moved fairly quickly. But if you would like to, well, of course, feel free to ask questions now, but if actually I'd like to have a look at these products, we have a stand at B61, which is sort of almost at the opposite diagonal of the exhibition hall, and we'd be very happy to talk to you and show you our products and answer detailed questions.